everyone. Great to have a chance to speak to you all this morning. Thanks very much to Emma and the best team for having us along. Also to Sharon, she referred, for kind of setting the context for this quite well. Couldn't plan it better myself. So yeah, as Emma said, I'm here today to talk to you about our plans for supporting R&D and innovation in kind of decarbonised heating space, specifically around our planned new thermal innovation facility. So I'll start with a bit of an overview about who we are and what we do. This is kind of a little bit of a new audience for us, so there's probably people in the room who aren't familiar with us. We are one of a few industry-facing innovation centres set up by the University of Strathclyde. We were founded in 2013 as Power Networks Demonstration Centre, and since then we've established ourselves as a leading research, testing and demonstration environment that kind of brings together industry and academia, again mostly around the kind of grid technology power system space. The picture there is of our existing facility in Cumbernauld. We have about 40 staff at the moment, and our facility at present is open access. We have a number of different collaboration models. We work with member organisations that we have. We've worked closely with them since we were founded. We also do grant-funded projects, and we work on a commercial basis as well. So we support development primarily from that kind of proof of concept stage through towards commercial design. So trying to kind of bridge that gap that exists in funding between the kind of academic focused early stage funding and more commercially focused funding initiatives. So this slide hopefully gives a little bit more detail as to what that actually involves. Some of the things we can offer start from high-level innovation support, kind of sharing our knowledge and expertise around the innovation process and how that works, helping organisations we work with identify their kind of requirements. And then into the more technical side, we have a highly flexible testing environment that I'll talk more about in a second. That's kind of aimed to accelerate the development of new technologies. We also have a quite sophisticated modelling and simulation capability, and that just kind of broadens our capability even further and enables us to provide a kind of whole systems support and validation. And both of these together mean that we can replicate real world conditions quite accurately, and that helps us to kind of shine a light on the next steps for the organisations that we work with and the technologies that they're developing as they move towards business as usual. So, Power Networks Demonstration Centre, the clue's kind of in the name. These are on the left-hand side, kind of our traditional area of focus and expertise, centred around the facility itself. And a disclaimer at this point, I'm not an electrical engineer, so a lot of this is outside of my realm of expertise. So we have a facility that allows us to replicate both high voltage and low voltage networks in a highly controlled, kind of safe environment. We can operate our kind of replica grid completely isolated from the main grid itself, and that lets us create all sorts of different load and fault conditions and scenarios that we wouldn't otherwise be able to do in a safe and controlled way. And it's also highly instrumented, so we get loads of data and feedback that we can then analyse and share with the organisations that we work with. We also have a real-time digital simulation capability, and that enables us to do what's called hardware-in-the-loop testing, which essentially involves plugging a physical piece of hardware into a system that interfaces with a simulation. And again, that enables us to test equipment under a whole different range of scenarios and conditions to see how it's going to perform in the real world. So the right-hand side of the slide there is where we're moving to now. So the left-hand side has been our kind of working model for the last 10 years, but we're currently undergoing a significant capability enhancement and facilities expansion, and that's focused on transferring and expanding our existing knowledge and expertise into the whole energy system space. And that's focused on decarbonisation of heat, which is what I'm here to talk to you about today, but also transport, the role of hydrogen, and the impact of all of this on power networks. So this evolution, as we've called it, there are a number of different aspects to it. First of all is the investment in our physical capabilities. We're also growing our staff numbers to enhance our expertise, broaden it, and facilitate the knowledge transfer from our kind of existing working areas into the whole energy system space. This slide has some examples on it of some of the stuff that we've done in this area so far already. So we're in a strategic partnership with the Energy Systems Catapult, and that's called the Whole Energy Systems Accelerator. We were part of DEREC, which is a snappy name for Driving the Electric Revolution, which is like a UK-wide project to accelerate electrified transport manufacturing. We're also one of the academic partners in the Hydrogen Accelerator along with St Andrews University, and that provides support for SMEs who are working or looking to work in the kind of hydrogen space. But it's that little dot on the map there that says Inchinnan, that's kind of the main focus of what I'm here to talk to you about today. That's going to be key for the future as we move into this kind of decarbonised heat space. So that's where the majority of our physical capability expansion is going to be taking place. There are a number of different projects happening in parallel on the site, which is, Inchinnan is just the other side of the runway from Glasgow Airport building. We're going to be occupying a section of the existing Rolls-Royce building there, along with another one of Strathclyde's kind of industry-facing innovation centres, LMC, Lightweight Manufacturing Centre. What we're interested in is that piece in the middle, that thermal innovation facility. So what exactly is it? Essentially, we're looking to replicate the ability and support that we can provide already in the kind of power system space, but with heating and cooling instead of power. So we have a physical heat network that allows us to connect equipment being tested to this heat network in a controlled environment that replicates real-world deployment and provides us with data and feedback about how that kit performs. And this could be heat pumps, boilers, whether it be gas or hydrogen-fired, CHP units, thermal storage technologies. It could be anything down to heat meters, heat interface units, anything kind of heat network related that we can connect into our network. We can work with. It's designed to a concept stage at the moment. We're in the process of procuring its construction, hoping to launch our tender for that this month, with a view to starting on site next year. So it's an exciting time. The design so far has been intended to maximise the flexibility of the system when it's built. So, yeah, as I said, flexibility is kind of at the heart of this. So it's designed to mimic real-world conditions at a range of scales and a range of temperatures. So anything from domestic scale technology right up to the kind of medium commercial scale. We're going to have a total heat capacity of about 750 kilowatts. So flexibility is really at the heart of the design. The system itself will consist of parallel heating and cooling networks, so full of hot and cold water, and they will interface via a series of heat exchangers. So those heat exchangers allow us to control the transfer of heat from the heat network side into the cooling network side. And by kind of governing that process and managing that transfer of heat, that basically enables us to mimic heat demand on the system. So we're able to replicate the load profiles of buildings or groups of buildings in any scenario. And we have a building simulation capability that will run in partnership with this, that will allow us to generate those profiles and translate them onto the system. We will have a total of 6 test cells, and these are the kind of physical connection points into the network for the equipment that we're testing. 2 of these will also have a hydrogen supply, and the site's got its own existing hydrogen supply system, and we're going to be taking that over as well. So hydrogen technology is included in what we can work with. Without getting into the sort of engineering nuts and bolts, it's probably easier to talk about this and the potential of it in terms of use cases. So, for example, say we want to work with a heat pump manufacturer, they might have a flashy new technology or a new configuration, something that hasn't been done before. They might have done some in-house kind of testing, proof of concept, and they want to see how it's going to work in the real world, but they can't obviously just throw this into a real world scenario and hope for the best without it being tested. So they would work with us to install their prototype, plug it into our network, so to speak, and then work with us to devise a range of, sort of test conditions and scenarios that they want to see how the unit would perform under, which we can then replicate using our system, and then collect and analyse all the data we get from that and kind of feedback to them to kind of inform their decision process about whether they might need to amend their design or whether they're ready to proceed towards commercialisation. Another example might be a local authority or a health board who are looking to decarbonise existing gas CHP networks or heating systems and replace their heat sources with low carbon alternatives. So we could replicate the demands that they have on their network, on our network, and then experiment with different technologies and seeing how we could meet those demands using low carbon alternatives, and not just on a single technology basis, but because we have 6 test cells, we can look at different combinations, configurations, how does thermal storage play into all that, and so on. Maybe they've got a program of building insulation upgrades going on at the same time. We can include that in our demand simulations to make sure we capture that, and then answer all the questions that come after in terms of system sizing and operation and so on. So lots of examples, and these are just some of the ones that we've thought of so far. And the benefit of designing in that level of flexibility means that we can come to events like this and speak to people like yourselves and others who are potentially going to utilise this resource and get your input and your ideas on how this might benefit you and your organisation. We think we are going to have a key role in kind of supporting innovation and development in low carbon heating. Well, certainly this facility is the only one of its kind in the UK, so we think we've got a key role to play. We're really keen to get your input on how we can deliver that support most effectively. So we are set up in next door. Come and have a chat to us. There's a few of us here. We'd love to have a chat, either whether it's about this or any of the other kind of stuff we can work with you on, and we'll be happy to answer any questions that you might have. So do get in touch. My email address up there as well. Come and have a chat. Thanks very much.